Before we start, let's understand together what problems you may run into if you overlook what I'm about to show you. First of all, the Safe NFT metadata provider is a project that I developed together with Daniel, also known as Ashlips, in order to protect the metadata from these snipers, who try to mint the rarest tokens in a collection by accessing the metadata or images before they are actually minted. You can simply go to our GitHub repo, the link is in the description, scroll down to the README file, and there you will find all the links to our videos about this topic. Please also remember to always check the version number when following our videos. In this case, I'm using major version number 1. This means that you will be able to follow this video with any version starting with the number 1. We are going to keep the code up to date by updating libraries, fixing stuff, and also implementing new features. So if we ever release a version number 2 point something, you will also find a new video explaining all the differences from the previous version. Remember, all versions starting with the same number are compatible with each other. Here, I'm assuming you already watched our video on how to set up the app for a brand new collection. But let's say you already revealed your collection. Would then this be enough to protect your users? Unfortunately not. In this example collection, I have a total of 12 tokens, and I minted 8 of them. Each token image contains the corresponding number so we can verify the match. I already revealed the collection, but there are still 4 hidden tokens, so now I implemented the Safe NFT metadata provider to protect the unminted ones. If you go to Etherscan and open the contract page, here we have all the transactions, and in the contract section we can request the URI for a given token. Let's try out token number 8. Same as with IPFS, we can open the URI and see what's there. Here is the metadata for token number 8. If I request the same resource for token number 9, I actually get the hidden metadata. And images are protected as well. If I open the image URI for token number 8 and then I change it to 9, I get a 404 error, token not found. It seems like my collection is safe now, right? No. Let's go back to Etherscan. We all know that the blockchain is a public ledger of all the transactions ever made. So if we look carefully here, anyone can spot the transactions where I actually changed my URI prefix. The last one is the one where I moved to the Safe NFT metadata provider. But this one here is the one from my previous reveal. Anyone can open this transaction, look at the input data, decode it, and here it is, the IPFS CID of all my precious metadata. I can now use any public IPFS gateway in order to see the content and access the metadata for any token I want. But how can we fix this? I created a couple of commands that you can run on the metadata provider in order to manage your collection in this particular scenario. Let's open the app control panel from the DigitalOcean's dashboard, and here we have a tab called Console. This allows you to run the commands directly inside the app server. It's actually a Docker container, but it doesn't make much difference in this case. In order to see all the available commands, you can run bin/console list NFT. This will show you all the available commands to interact with your collection. For example, we can run bin console NFT total-supply, and this will return the current total supply directly from the contract. This can be useful for debug purposes. Another interesting command is shuffle collection. Let's see what it does. First of all, you can use shortcuts. For example, if I just type shuffle here, the app knows that there is just one command matching this name, so it's gonna run shuffle collection. I'm gonna stop this because I want to show you one more thing. You can always append --help to any command in order to get further information about the available arguments or options. Here you can see that we can pass a minimum or a maximum token ID in order to shuffle a specific range of tokens. This would keep the rest of them as they are. This is exactly what we need in our case. Remember, we need to keep tokens from 1 to 8 as they are, since they are already minted, and we want to shuffle the rest of them. Here you have to make a decision. You can either pause the minting while you are deploying this solution, or you can leave a certain amount of tokens untouched and shuffle from a higher token ID. You have to ensure that nobody is gonna mint a token while you are busy shuffling the same token ID, otherwise someone would get really upset. So here I'm gonna shuffle starting from token 9, I confirm the action, and it shuffles the tokens and clears the cache. As you can see, a new shuffle mapping has been generated. But what does it mean? On the cloud storage, we have our metadata and assets files. The app is always gonna leave them untouched, so you can always get back to the original data. But if I click refresh here, you can see that now we have a mapping.json file. This file simply contains a JSON array of token IDs which have been shuffled as requested. So here we can see that token 1 is number 1. Token 2 is number 2. Tokens from 1 to 8 are in the same exact position. They must not change. From token number 9, we start to see something different. Token 9 is number 11, 10 is 12, 11 is 9, and 12 is 10. The app will now use this map in order to return any token metadata or image. If we ask for 9, we get 11 back. Let's try it out. If we open metadata for token number 9, it's still hidden. Let's mint it quickly. Once our transaction is confirmed, we can check out OpenSea. And here it is. Now we minted token number 9, but we actually got an image with an 11 in it. So it works. Now we can do some fine-tuning on the metadata. We now have the image and attributes of token number 11 attached to token number 9, but the name should be 9. There might be many places where you actually added the token ID or image URI inside the metadata. So how can you update those properties dynamically? Well, this is really easy to do. Just open up the Settings tab for your app, click on the component, scroll down to Environment Variables, and here you can see Metadata Template. This variable is pretty powerful. Let's run a quick test. Let's input a simple JSON object with a name property and a custom text value. I also use this keyword here to reference the token ID. Then I can save my changes and DigitalOcean is going to build my app again and replace the old one. While we are waiting for the app to build, I want to show you where to find the available keywords that you can use inside the JSON template. On the repo, go to the src folder, then metadata updater, and then templated metadata updater.php. Here is the code that updates your metadata on the fly, and on top of the class is some documentation about how to use it. We are gonna see another example in a minute. Once the build process is completed, you can refresh the metadata and you can see that the name is updated correctly, including the token ID. You should do all of these before the new tokens get minted, but even if you have to change something on the fly, you see that OpenSea allows you to refresh everything as usual. And you can also use this feature in order to update or fix all of your tokens at once, even the old ones. So now I'm gonna show you an example with multiple properties. Let's open a simple JSON editor from Google. I'm gonna use all the keywords here. So I add a custom name, a custom description where I insert the asset URI, and the last property is gonna be edition, containing an integer value corresponding to the token ID. Please remember, do not leave a trailing comma after the last entry, otherwise your JSON object will be invalid. I can simply copy this text here and paste it inside my environment variable. I save again and wait for the build to complete. Once the app is ready, we can refresh our metadata, and as you can see, everything is updated according to the JSON template. At this point, the app is fine. But how can you move back to IPFS once your collection sells out? Don't worry, we have a solution for this. On the cloud storage, you now have all of your original files plus the mapping.json file. Please remember to save a copy of the mapping file so you can always recreate the shuffled collection starting from the original data. Now, I told you that the app is never touching your original data, and that's true. If I preview token number 9, it says 9, not 11. But you can use 2 dedicated commands to export all your new assets and metadata in no time. Let's open the app console. Type bin, console, NFT, and then export assets, and hit enter. Confirm the action, and your tokens will be exported to a dedicated folder on the remote storage. And here is our token number 9 with the new content. At this point, you can upload the new assets to IPFS. I recently made a video about how to upload a whole collection in about 1 hour. In my case, I'm simply using the Piñata web interface since I just have a few tokens. Now I can copy the CID of the new assets folder and export the metadata. If you run the export metadata command without passing any argument, you're gonna get an error. This is because it requires a URI prefix in order to update your metadata correctly. So I run bin, console, NFT, export the metadata, and then the new URI prefix. Once done, you will get another folder on the remote storage, and all the JSON files will contain the updated metadata, including any reference to the assets on IPFS. Upload this last folder to IPFS and you will be ready to switch back to a decentralized storage as soon as your collection sells out.